Hey class, this is lesson 9.2 on exponential functions. So exponential functions, we're going to kind of be going off of what we talked about yesterday with geometric sequences. And exponential functions are if we're going to look at our y values in our table here, and they need to be increasing by a factor or a common ratio of a multiple of some number, and it needs to be consistent. So like on this first example, everything is increasing by a multiple of 3. Okay, so in terms of how it's going to look as an equation then, it needs to take this form. So it's going to be of the form a times b to the power of x, where a is not 0, b is not 1, and b has to be greater than 0. So what we're going to look for is if it's an exponential function, it's going to have x in our exponent slot. So in the example above here, our pattern for the example is 2, our starting value, what it started with for our y's up here. And then this 3 is going to go next, because that's what it's increasing by each time. That's our common ratio. And then it's to the power of x, however many times, or however many days you're going to do that in this example. So again, it starts with 2, increases by a common ratio of times 3 each time. Alright, so let's try a couple story problems here. So this first one shows, this function shows the amount of money in a certificate of deposit after X years, and we want to know how much money there will be in 6 years. So we're going to just plug in X equals 6, and so when we go to evaluate that, we'll say f of 6 equals 500 times 1.035 to the power of 6. It's as simple as that, and then you just need to punch that all into your calculator. And since we're rounding, we're going to round to 2 decimal places since we're dealing with money. And when I punch that in, I should get $614.63 then. Okay, the next one then. On this one, it says it gives a function where x is the time in years, and it models the population of a city. And so we want to know the population in 7 years. So we're going to just plug in 7 for x. So we're going to, into our calculator, we're just going to type in 200,000 times 0.98 to the power of 7. And remember, we're dealing with population, so we're going to want to round to the nearest person. So when I round to the nearest person, I get 173,625. And since it's population, and it's a story problem, we want to label. So our label would be people then. Okay, the next one then, they give us an equation that models the width of a photograph in inches after it's been reduced by 25% x times. So we want to know what's the width going to be after it's been reduced 3 times. So again, we're going to just plug in 3 for my x value. I don't need to do anything with that 25%. That's just giving us some unneeded info as far as the problem goes. I'm just going to plug in 3, punch 8 times 0.75 to the power of 3 into my calculator. And when I get that out, I get 3.375. And my label is inches. Okay, so these ones are really pretty easy. You're just plugging and chugging for the most part. So let's try this next one now. Here we need to be able to tell if we have an exponential function on our hands or not. And so remember from the front page, it needs to be increasing using multiplication at a constant rate. So what we're going to do is just put all of these points into our table here. So 0, 4, 112. 236, and 3, 108. Now our x values are increasing by 1 each time, so that's good. What we want to focus on next then is our x values, and you can see that this one increased by times 3, increased by times 3, and this one was multiplied by 3 as well. So since our y's are increasing by a multiple of 3 each time, we're using multiplication to increase them, then we can say that yes, this is an exponential function, because the rate of change in the y's, rate of change is multiplied by 3. Okay, so it's always got to be multiplication. in the y's in order to be an exponential function. So on this next one, let's go ahead and do the same thing. I'm going to put my ordered pairs into my chart here so we can see them a little bit easier. On your assignment, you can either do this or not. It doesn't matter. If you can do it just from the list up above, that's fine too. So my x's are increasing by 1 each time, and then I want to look at my y's. So here, I either multiplied by 0 or I could have added 64. And if you notice, what's happening is I'm adding 64 each time, so that appears to be my pattern. So since this is increasing by 64, but we're just adding, then this would be no, it's not an exponential function. It has to be multiplication. Has to be multiplication in order to be exponential. This would be a linear function because this would satisfy our rule for a linear function, but not exponential. Okay, let's try one more of these. So again, I'm going to just put them, all my points, into a table so I can see them a little bit easier. Okay, my x's are increasing by 1 each time. On my y's then, what's happening is it looks like I'm adding 1 each time here, but then here I added 3 randomly. Multiplication doesn't work for anything. I multiplied by 0 on the first one. So since multiplication doesn't work, it looks like I'm adding, and I'm adding inconsistently at that, so this one would be another no then. So no, the y values aren't multiplied. Make sure you're explaining how you know on your assignment today. Okay, why don't you try this last one on your own then. So go ahead and pause the video and try it out, and then you can check your answer. Alright, so then the last thing we're going to do today is how to graph these exponential functions. So in order to do that, we're just going to make an xy table. We're going to choose several values of x. We want some positive, some negative, and some 0. You need at least 3 points in order to graph these. I would recommend more like 5, like what we're going to do here in these examples. And then once you've made your XY table, you can just plot the points and graph them. As simple as that. We've done this lots before. So I'm going to pick some negative points. I'm going to do -1. I'm going to do 0. I always want to do that one. And then I want to do 1 or 2 positives as well. So I'm just going to go -1, 0, 1, 2, 3 for this one. So then all I need to do is I just need to plug in -1 in for x here. So into my calculator, I'm going to type 0.5 times 2 to the power of -1, and I get 0.25. I'm going to do the same thing with 0 then, plug that in for x, punch it in my calculator, and I get 0.5. Here I get 1, here I get 2, and here I get 4. So then I just need to go and plot these points. So -1, 1/4, 0, 1/2, 1, 1, 2, 2, and 3, 4. So when we plot these exponential functions, we're going to always get a curve that looks something like this. So it's going to be, the points are going to be kind of close together at one point in your graph, and then they're going to quickly get much bigger as you go up. And so that's how you can tell it's an exponential graph. Remember that a linear function looks just like a straight line. Quadratic, we learned about last chapter, that's a parabola. And then exponential here is where it's going to start off really slowly climbing, and then it's going to take off all of a sudden as it goes up. Okay, so let's try a couple more like this. This next one here, I'm going to pick, this time I'll go maybe -2, -1, 0, 1, and 2, just so I get some more negatives in there this time. As long as you have at least 1 negative, 1 positive, and a 0, you should be good though. So I'm going to plug in -2 in for my x value. So 2 to the power of -2 gets me 1/4 again, or 0.25. Here I get 1/2. Then I get 1. Here I get 2, and here I get 4. So I'm going to go ahead and graph that then. So -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. And then once I've got my points plotted, I can go ahead and connect that. And so you'll see it looks really similar to that first one we plotted. So it starts off climbing really slowly, and then it takes off really quickly. Again, that's going to be the case with all of these quadratic functions. Okay, so let's do one more together. I'm going to pick my x's, so -2, -1, 0, 1, and 2 again. Those are just good ones to stick with. Otherwise, if you get too high of numbers, your graph can kind of grow to a really large number, and then it's harder to graph. So go ahead and plug those in. Remember, if you're going to plug this into your calculator, you need parentheses around it. Use your divided by sign then to make your fraction. Or you could just put this as 0.25, write it as a decimal when you go to plug it in. That might be easier. So go ahead and punch those in, see if you get the same things I do for each of these. And then once you've got all your points, you can go ahead and graph them. Alright, so you can see this one kind of goes the opposite way, so I'm going to start at -2, -16, -1, -4, and then here it gets really close up at the top here. So this one's kind of going the opposite way as the last two we graphed, but it's the same thing. It starts off really, they're all really close together here, and then they spread out really quickly and get bigger. So it's the same shape, it's just kind of flipped upside down, and we'll be talking about why that is later. Alright, so then I want you to go ahead and do this last one on your own. Pick your own x values, plug them in, and then you should be able to graph from there. After that, you should be ready to go on your assignment.